Hi, everybody. Welcome to another Chats with Children. I hope you're safe and well. Today, I'm delighted to be joined by Tim Spicer, who is Senior Scientific Director, Department of Molecular Medicine from Scripps Research, Florida. You can tell that by his lovely background there. And he's also the incoming SLAS President in 2022. And Dr. Sinead Knight, Principal Scientist for Sygnature Discovery. Hopefully, I pronounced that correctly. And now, Sinead is not calling in from Florida, but I'll ask in a sec where she's calling you from. And today we are going to be talking about lab automation, specifically 3D biology. So, Sinead, Tim, lovely to see you both. How are you?
Wonderful.
Great, thanks. Thanks for the introduction. Yeah.
Well, it's lovely to see you. And Sinead, out of interest, where are you calling in from? Because we can guess Tim's calling in from sunny Florida, but where are you calling in from?
I'm calling in from Manchester in the United Kingdom.
Oh, right. Okay. Well, I was in Birmingham for 2 days yesterday, actually. My first time out of the house on a train and public transport. So it was quite a bizarre experience. And then had a live show for 2 days. So very, very surreal, to be honest. Well, it's lovely to see you both. So before we start talking about lab automation, specifically 3D biology, would you mind just giving a quick overview on your own background? So Sinead, would you mind starting?
Yeah, sure. So I'm currently a principal scientist with Sygnature Discovery, but I have over 15 years experience in the drug discovery, be it target validation or hit to lead. From HTS to target validation. So I've been all over the block. And I have always had a huge interest in 3D biology and translational assays and how they can affect cascades and the overall success of drug discovery. And that's where my passion lies.
Mm-hmm. Brilliant. And Tim, your background, if you don't mind.
Yeah, sure. So I currently co-direct the screening center at Scripps Research in Florida. As part of that, we embark upon new technologies and developments, and that's what's led me to the 3D. But really, I attack any therapeutic need of unmet druggable targets.
Fantastic. Okay, so one thing I should have added is you're also both co-chairs for an upcoming SLAS Symposium. So before we start talking about 3D biology, would you mind giving a quick overview on SLAS for those not familiar with the organization? Tim, would you like to do that?
Yeah, sure. So SLAS, is an organization that really brings together like-minded folks in early drug discovery. So it ranges from folks that are in automation to informatics to chemistry to biology, you name it. And it really is focused largely on that early drug discovery regime, if you will. And it has multiple ways to interact, whether it be a symposium or whether it be a international conference, also through the journals. We have 2 journals, Discovery and Technology. It's really a broad-based organization. I think there's roughly 20,000 members worldwide that bring us together to do what we like to do, to network and communicate and be part of a great organization.
Brilliant. And Sinead, have you got anything to add to that at all?
No, that sounds great. Yeah.
Fantastic.
Sorry, Tim. Yeah.
No. So let's start with a sort of broad question, though. So obviously, you mentioned drug discovery, and it's been at the forefront very much in terms of development of vaccines over the last 18 months or so. So what are your thoughts on how the pandemic has impacted the use of automation in research?
I think it's been massive because I think it's shown the power of automation. You know, when the pandemic started, there's huge pressure to get tests turned over, and now we're seeing hundreds of thousands of tests being turned over in the blink of an eye and in a day, and all of that was made possible by expertise in automation and sophisticated automation systems. And I'm sure in the production of the vaccines, automation has played a huge role as well. I think it's had a hugely positive awakening of how, you know, automation can impact on research and at a scale. And also, I think if you take a step back as well, from our own perspective working in the lab every day with projects, I think we've seen, you know, some reagents that are associated with automation, like tips and plastics, they've become in very short supply because, you know, they've been in more demand because of the pandemic. So people have had to look to different ways to do things, miniaturizing more and that. So yeah, I mean, it has had a huge impact, yeah, but positive, and then in a challenging way to kind of compete for those automating reagents that we use every day. Yeah, but yeah, I think it's, you know, it's really shown how powerful it is.
I mean, have you got anything to add to that from your perspective?
No, that was very well said. I think if I were to say anything else, I know for sure that automation sales and exhibit is going to go up for SLAS. So it's a very positive thing overall. Yes.
Right. So let's now start talking about the SLAS new hybrid symposium series. I know obviously SLAS have had two very successful events that they've always done internationally, as you just alluded to a bit earlier on with the big show in January, the international event, and then also a European event as well. They've launched these 4 new symposiums, or the symposium series. So what new or hot topics have they sort of included in the series that SLAS hasn't addressed before?
Yeah, so we have a number of symposium that are still up and coming, and including the building biology and 3D that we're about to discuss. But we also have the European sample management that I believe is up and coming at the Crick Institute, which will showcase lots of automation, as we just described, around how to deal with things in early drug discovery and even some things around the pandemic. And then we also have the building biology and 3D comes up in La Jolla in late October. And then there's also an artificial intelligence and AI symposium that we're putting on. I believe that's in Boston in November.
Right, brilliant. So let's talk more about the event in La Jolla. It's spelled actually La Jolla, actually, everybody, in case you're wondering, but it actually pronounced La Jolla, as I was corrected earlier by Tim. So this is a 3rd symposium in the series, and as you said, it's called Building Biology in 3D. And it's on October the 26th to the 7th, but all the details will be above the video. So you don't have to write this down, anybody who's watching. I will put the links to everything above that. So first, let's kick off with, what is 3D biology? Why is it important? And what benefits does it bring to users that weren't available to them until the recent past?
Yeah, I can make a start on this, Tim. Yeah, so I think, to put it quite simply, 3D is a way to mimic in vivo processes conveniently in vitro, so people can access kind of complex biology in vitro in a simplified system. And and why is it important? It's important because it allows us more complex translational assays that can benefit all aspects of drug discovery, from hit to lead, from target identification to hit identification. So it really does impact on all phases. And what is important, how it has affected us in the last 5 years. I think the last 5 years has seen a huge explosion of advances in 3D technologies, not only in availability of more complex cells, but more complex methods of making the 3D models, such as organoids, but also importantly, much more sophisticated ways of analyzing them in our molecular imaging techniques and more sensitivity. So it really is a massive explosion in the last few years, and has a huge influence on how we run drug discovery cascades, and has a massive positive impact on the translation of those. And it's really exciting era in it because of all the advances we've seen in the last 5 years. And it's funny because it's not actually a new technology, but I think, people have been putting embryonic tissues into culture since the early 1900s, but there is lots of new things that have happened in the last 5 years that will be really beneficial to catch up on at the Building Biology and 3D Symposium coming up.
Brilliant. And Tim, anything to add to that?
Yeah, again, well said. I think the scalability in the last few years has helped create that explosion, which, that's some of the technologies have improved, and they've become more cost effective and affordable, which has really catapulted the ability of, what I'd say, more common research to approach 3D.
Yeah, that's true, Tim. And also to mention as well, we have a track in the Building Biology and 3D Symposium on HTS applications for 3D biology. So and always HTS will have a mind on miniaturization and cost saving, because they have to do things at scale. So we have a few interesting talks lined up in that track as well. That'll be good to watch out for.
Brilliant. Okay, so how readily is 3D biology available to researchers in terms of the utility, technologies, and automation?
Yeah, I can take a crack at this one. So as Sinead alluded to earlier, it's been around for a long time. And it's not that folks didn't appreciate the capabilities or the 3D-ness of the models that were available to researchers. It's just that they always had some impediment, some hurdle that made it difficult to approach 3D in a sort of scalable way. So I think the automation requires speed and efficiency and agility in certain biologies and certain technologies. And in the recent past, what's happened is multiple vendors have come up with really matrix-free ways of manipulating plasticware that they put into microtiter plates that allow researchers like myself and Sinead to really form 3D features in their cellular models, whether it's a direct tumor or it's a cell line or whatever. And you can get into debate about spheroids and organoids, and maybe that's a good reason to come to our meeting as well, so we can talk about those things. But ultimately, it's been the recent past, the last 4 or 5 years, where these new technologies have given us more affordable, faster, cheaper, better ways to do 3D and then implement those.
Right.
Yeah, I agree, Tim. And also, I think it's the variety of things that are available now. So sometimes one model won't fit all the 3 cell lines you want to look at, but there just seems to be a bigger variety of things available, from simple ultra-low adhesion plates to magnetic beads to 3D print spheroids. So it just seems to be a lot more flexibility out there to help people build their assays that they need.
Yeah, and then the automation has taken hold too, right? So all of those things you just mentioned, right, are all compatible with what I would call simple automated tools, which are available to all of us. But also imaging, right? So imaging in 3D has been a complex problem for a long time,
Sure.
and now computers have really taken hold and put together nice packages of instrumentation and suites of software that allow us to do it so much better than we used to be able to do. So all these things are going to be showcased. Very nice.
Yeah. You touched on that though. So one question comes to mind when I'm listening to say that is how much of an impact has things like machine learning and AI had in terms of helping with 3D technology?
Yeah, I think it's had a huge impact on the image analysis. I think because you obviously you'll be able to extract a lot more information from the phenotypic changes in the cells, and yeah, so it has had a very positive impact, and I think we have a track on that as well.
Yeah, for sure. So, you know, cell painting is a pretty intense, detailed endeavor to try to, you know, ascertain what's happening in tumor cells or cancers, for example. And there's folks that apply that now to 3D. You can imagine that spheroids or organoids don't always sit in the center of a field of view, right? So depending on your magnification, you have to be able to drill into that faster and better. And they use AI applications to allow that rastering to happen and really speed up the efficiency of the reads, right? So you can imagine that if it takes 24 hours to read one 1536 well plate and multiple Z stacks for a spheroid, and you can't find that particular spheroid in the well that you're looking for easily, that would be a big problem. And I think it's much faster than that now because of AI. Brilliant.
Okay, so who are the key players then, from your perspective, making 3D consumables at the moment?
Yeah, so a number of vendors are out there now, and it's you know, Insphero is a pretty good company to take a look at. They provide spheroids in the well already formulated and ready to go, qualified, QC'd. I would take a look at the Corning folks, very, very good at using microgeometry cavity plates in all sorts and sizes. They also have other flasks and other plate technologies that are very, very interesting and may suit your application needs. Grounded Bio One has been very, very good at using nanoshuttle technologies and also applying cell repellent plasticware. And they're also a very good choice for doing anything in 3D in all formats. And they have some advantages around aggregating in a very fast and efficient way using nanoshuttles and magnetic drivers and such, which are very cool and very adaptable all the way up to very high scale automation, which I'll showcase.
Brilliant, fantastic. Well, look, it sounds like a really exciting event. I wish I could be there, but I don't think they're going to let me in the country at the moment unless I go through South America or Mexico, which I don't think I can do. So I wish you a fantastic event in October. Where can people get more information, not just on 3D biology, but obviously the event itself?
Yeah, so at any given time, if you reach out and just Google SLAS, you'll find our direct home site, and that's always going to lead you to the next level of symposium. You can certainly reach out to ourselves directly if you need be. As the future president of SLAS, I'd be happy to push you in the right directions if you ever get lost, and then go from there. Maybe Sinead has some other ideas.
Yeah, and I think yeah, go on the website and look at the detailed, exciting program that's lined up. I think that's a good way to find out more information on it. The program will be uploaded on the website as well for the building biology in 3D. So it's a good information source to grab your attention as well.
Fantastic. Well, I'll make sure people don't have to do the searching, because I'll find the link and I'll put it above the video so they can click directly. So all I can say is I wish you a wonderful conference. I know you're chairing it, both of you are, so I hope it goes really, really well for you as well. There's always a bit of pressure when you're chairing it to make sure everything runs smoothly, and you stop those arguments breaking out. Although a bit of debate is always good, isn't it, when you're chairing? You can get things going a little bit. So I wish you lots of success. Thank you very much for sharing the information about 3D biology. I've learned something new, but then I'm bound to. I'm not a scientist. I learn every time I do these things. So if viewers have watched this and you'd like to know more about 3D biology and the symposium, as I said, the link will be above the video. If you've got any questions of Sinead and Tim, though, please put them below the video. I'm sure they'll be only happy to see them and answer any questions you've got around 3D biology or about the symposium itself. And you can message them directly on LinkedIn, as they both are on LinkedIn, I'm sure. So all that's going to say is thank you very much, Sinead, in hopefully sunny Manchester today. And certainly I feel jealous, so I don't even know I want to say this, but you have a lovely day as well in sunny Florida, Tim. And it's sunny here in Surrey, so I can't complain. So I wish you all a fantastic night. Thank you very much for joining me. Look after yourself.
Thank you very much.
And thank you, viewers, for watching, as always. And until next time, stay well and stay safe. Bye-bye.
Thank you.